Let's try and do this differentiation. You're supposed to find the derivative with respect to x of this function that's sitting inside this bracket here. It's not in the right form though. You've got to go to the square root of x squared. Well, that equals x. And 2 to the minus 4 means 1 over 2 to the positive 4. That's 1 over 16. This x is to the minus 4. Now it's in the right form. The derivative of x is just 1. 1 times 1 in front, bring it down 1x to the 0, it's just 1. Minus 4 times 1 over 16, that's a quarter. When you bring it down 1, it's x to the minus 5. Next question, you're finding the derivative, but this time with respect to t. They should have said that t cannot equal 0. Otherwise, this is like undefined. But you just go, let's put it in the right form. T squared divided by t is t. 5t over t, the t's cancel. You see, of a fraction like this, it gets divided into everything. And 6 over t means 6 times t to the minus 1. Now I can do it. The derivative of t is 1. The derivative of a constant is 0. And minus 1 times 6 is minus 6. Bring it down 1, minus 2. Next question. This x plus 2 cubed, you can write x plus 2 times x plus 2, multiply it all out, and then multiply it by another x plus 2. It would take a while, but if you know the binomial expansion, the first thing's going to be cubed, the second thing's going to be cubed, and then it's 3 times x squared times 2, and then 3 times x times 2. That should be 2 squared, b squared. And there you go. That's what it looks like. X plus 2 cubed, if you multiply it all out, it's x cubed plus 6x squared, 12x plus 8. Now in the bottom, you've got the square root of x, which is x to the half. Now this is it's a nasty question. I've never seen one so involved, but it's an exam question, so I guess it could happen. Now all you do is you subtract. 3 minus a half is 5 halves. 2 minus a half is 3 halves. 1 minus a half is a half, and then we're just dividing by x to the minus, so it becomes x to the minus a half. See how I've put everything in the form of ax to a power? Because now I can do it. I multiply 5 halves in front and bring it down 1. 3 halves times 6 is 9, and then 3 halves minus 1 is a half. Half of 12 is 6, bring it down 1. Minus a half times 8 is minus 4. Minus a half minus 1 is minus 3 halves. And that's your final answer. This one's pretty straightforward. It says, given that f of theta equals this stuff, find f double prime of theta. It just means take the derivative twice. We'll learn what that means later on, but you just do it twice. So here's the first time. It's 3 times 2, bring it down 1. 2 times 3, bring it down 1. And then do it again. 2 times 6 is 12 theta. The derivative of minus 6 theta is just minus 6. So with respect to theta, you find those derivatives. Question 9. This one's a bit weird. It says that x minus 2 can't be 0. We're supposed to find the derivative of this function of y. But we've got to put it in the right form. We're going to have to factor out this y here. And factor this one as well. Now we see x minus 2. You see we're going to divide by x minus 2. That's why it can't be 0. Now we get a simple function, y equals 2x. So dy dx, it's just 2. The derivative is just 2. 1 times 2 and bring it down 1. Last question here. What is the derivative with respect to x of this? Well, it's 2 times a, which is 2a. And then you bring it down 1 is x. This a, you just treat it like it was a constant. You can't find that derivative, so you just leave it alone. But the next question is pretty weird. It says, find the derivative, but with respect to a. So pretend a is the variable that's varying here. Well, the derivative of a is 1 times a. It's just 1. But the derivative of this x squared is like a constant. So the derivative of a is 1, but this is in front. This is sort of like x squared a. So your answer would just be x squared. And that's it.